already know.
Let's talk about magnetism.
I have my opinion on it.
That's fine. That's fine. You can have your opinion on it. All right. So today's the day I'm going to pull the lodestone out.
The what?
The lodestone.
Oh, what's that?
You have a lodestone?
I do. Magnets occur naturally within rocks like lodestone. So lodestone is simply a natural magnet, a rock that's magnetic. Do what you like. They're going to be posted later. The word magnet is derived from a place called Magnesia because magnetic rocks are common there. Okay? So there's an area of Greece known as Magnesia. Oh, and I don't know what happened to it, but it should be down here, the picture.
Magnets occur naturally within rocks.
I don't know. Anyways, the story goes that a Greek shepherd was out with his spear thingy and noticed that this rock was sort of attracting his spear, and he noticed that it was like magnetic, basically. And that area of Greece is called Magnesia. So that's why we get the word magnets.
That's cool.
Anybody ever taken milk of magnesia before?
What?
It's like an upset stomach kind of remedy. It's like a creamy kind of thing. No?
Sure,
It's just basically, it's milk with ground up magnets.
Oh,
So I was lying. Admit it.
that'd be quite gross.
Like, oh. I'll see a picture. He said, how big it is in bigger.
Oh yeah, someone asked me that. How big is this magnesia region? Well, let me see what I can find out. See, there's the picture there. Okay. So there's Greece. Anybody here go on the Greece trip? No? Okay, so it's this area here of Greece that's known as Magnesia. How big is it in relation to Rocky Mountain National Park? I think it's actually smaller, I believe. I can't remember. Someone asked me that. I should probably get rid of that.
So is that like a province?
It's like a province, yeah.
I was expecting
Province
it to be like huge.
Yeah. No, it's not that big.
Greece isn't that big.
Actually,
Not that big.
We found in Magnesia?
Pardon me? No, that's just where they're first found. It's actually got to do with volcanic activity. There's probably volcanoes there. Yeah.
Volcanoes are cool.
Okay, so there are certain types of magnets. I'll get the lodestone out right away. Certain types of magnets. Some are called permanent. Obviously, permanent just means yeah, they're magnets permanently. What else we got here?
Straight up and down.
The second type is electromagnets.
Look, we're at the North Pole.
The second type of magnet is what's called an electromagnet. When an iron bar is wrapped with a current-carrying wire, the bar becomes a magnet, right?
What they use in like garbage dumps, right?
Yep, exactly. Yep. Or like auto record, right? They put the electromagnet on, they pick up the car, and then they turn it off and it drops, right? Exactly. So we got an iron bar wrapped with a current-carrying wire. The bar becomes a magnet. It ceases to be magnetic when the current is off, right? So you can use that for picking things up. That's called an electromagnet. They're also used in car starters. That's the solenoid in your car. If you have one of the old-style doorbells at home, anybody got an old ding-dong bell at home?
Oh,
Yeah. Hunter, would you be able to take the cover off the ding-dong bell at home?
Probably on the back one, yeah.
Oh yeah. Okay. Have a look at that, and you should see like an iron sort of bar with wire around it, kind of thing. And then when you get someone to press the button, you'll see it becomes magnetic, and it actually pulls the iron bar into it. And then when that's the ding part, and then when you let go, goes back out, and that's the dong.
like don't most people. Doorbells.
Yeah, but not everyone has old style. A lot of the new ones now are
What do you mean?
electronic.
I mean,
Like an actual bell that actually, is struck and actually rings. It's not electronic.
I don't think I
I
got
don't
an
know
old
now
one.
Yeah.
at all. These guys.
You live in the lower.
It's kinda not- I actually have one like that. Hunter, you have a look and maybe take a picture and bring it in for us.
That's so here.
I don't know if it is. I think
That's
it's
all you're So then you go.
older house.
Yeah. I actually try to find an old one and bring it
Good
and
Lord.
have it in the class, kind of. Okay, so electromagnets is the second one.
Beaver
The
Dam.
third one is what we call a solenoid. Okay? A solenoid is simply a coil of wire itself. And I'm going to show you one here. 2, 3. Wait. These are all solenoids. Okay? If I had a nail or a bar through there, then the bar would be what's called an electromagnet. But the solenoid itself, and this is what you'll see in the doorbell, right? So there's the leads to it, right? Someone presses the button, it connects your house's electricity to it, and makes this into a magnet. It pulls an iron bar through. There'd be a bell on this side, and it would come through. There'd be a spring on it. would pull it in, and it would go ding, hit the bell over here, and then when you released it, then it springs back, and there'd be another bell over here, and that's where the dong sound comes from. You know, ding dong. If you flip them around, then your doorbell would go dong. It would go dong ding. No,
Yeah, ding dong.
no, it'd be dong ding.
My grandma.
You don't want to hear me sing, do you?
Chris just played a song to do that.
That's called a solenoid, Chris. Solenoid. There's also a solenoid in your car starter.
North Pole, man.
Okay, lines of force. Now remember, we saw the electric lines of force, magnetic lines of force, almost identical. The only difference being they're magnetic instead of electric. Okay, so in all cases, the magnet produces magnetic lines of force that attract or repel other magnets. The magnetic lines of force form a magnetic field. Magnetic field. All lines are said to originate at the North Pole. That's just a convention. We've just all agreed magnetic field lines start at north. Go to south.
Polar subject.
You can also consider the lines to point in the direction that a North Pole test magnet would be pushed. You know how we had the positive test charge? If you could come up with because every magnet has a north and a south pole, if you could come up with just a North Pole one, which direction would it go? Okay? So you need to know that they go from north to south. From north to south. He repeats it one more time. From north to south. Now, legal disclaimer, that's only true on the outside of a magnet. It's only true on the outside of that. On the inside, they actually travel south to north. And that's true also for a solenoid, okay? So if the solenoid is my magnet, on the outside, they're going to go from north to south. Then on the inside, they're going to go south to north, basically making a circle. Okay? You need to know that. I will stop there, I think.
Okay. The end.